The Al-Taji command bunker stopped transmitting at 4:47 hours on February 27, 1991. Not degraded signal. Not intermittent. Just gone. The coalition's SIGINT crews monitoring Iraqi military communications noted the cessation in their logs. One facility that had been coordinating Republican Guard movements in the Medina Division sector went from active to silent in the span of a single minute. The transcripts show normal radio traffic at 4:46 hours. At 4:48 hours, nothing. What they didn't log, because they didn't know yet, was that everyone inside had stopped existing at roughly the same moment. I'm starting here because this is where it ended. The Gulf War air campaign hit thousands of targets over 6 weeks. Most of those strikes degraded capabilities, destroyed equipment, killed some people, and missed others. Al-Taji was different. Al-Taji was absolute. The bunker sat 15 miles north of Baghdad. Soviet engineers had designed it in the mid-1980s as part of Iraq's Hardened command network. 20 feet of reinforced concrete over the operations center, 12 feet of earth and rock over that. Blast doors rated to survive near-miss nuclear strikes. Redundant ventilation, independent power, communications lines buried in concrete conduits. The Soviets had done this before in their own territory. They knew what they were doing. The Republican Guard officers working inside that morning believed they were untouchable. They had reason to. For 6 weeks, coalition aircraft had pounded Iraq. Some bombs had hit the bunker complex. The structure shrugged them off. Conventional bombs couldn't penetrate that much reinforced concrete. The officers knew this. Their Soviet consultants had shown them the math. At 04:47 hours, a single bomb proved the math wrong. The weapon weighed 4,700 pounds. It hit the earth above the bunker at approximately 600 miles per hour. It punched through 12 feet of rock and soil. It penetrated the first layer of reinforced concrete. It kept going through the second layer. It detonated inside the operations center. What happens when 600 pounds of high explosive detonates in an enclosed space built to contain blast pressure is not something I can fully describe here. The overpressure alone would have been unsurvivable. The bunker's own structure, designed to keep explosions out, kept this one in. The SIGINT logs note the silence. They don't note what caused it because the crews monitoring communications couldn't know what had just happened inside a hardened bunker 15 miles north of Baghdad. That information came later, after ground forces reached the site, after engineers examined what was left. Here's what I want you to understand before we go backward through how this became possible. The officers in Al-Taji didn't die because of some intelligence failure or tactical mistake on their part. They died because American weapons engineers had solved a problem that didn't have a solution 3 weeks earlier. The Soviets had built a structure that could survive anything in the American inventory as of early February 1991. By late February, that was no longer true. The Al-Taji bunker became a tomb at 4:47 hours. What made that possible started weeks earlier, with engineers in Texas working a problem that had no answer yet. We're going there next, but I wanted you to see the end first. The silence that followed 1 minute of radio traffic. The absolute cessation that happens when a hardened shelter stops being shelter. Coalition ground forces reached the Al-Taji complex on March 3, 1991. The engineers who entered the bunker filed reports. I've read 3 of them. None use particularly clinical language. The exterior structure looked almost intact. That's what hardened construction does. The blast doors were still in their frames. The ventilation stacks still stood. From outside, you might think the place survived. The entrance tunnel told a different story. The overpressure had vented through every opening. It had blown the blast doors outward against their hinges. The doors weighed several tons each. They'd moved. Inside the operations center, the reinforced concrete walls showed cracking patterns that structural engineers recognized. The bomb had detonated somewhere in the middle of the main room. The explosion had nowhere to go. The pressure wave reflected off the walls, concentrated, reflected again. Everything in that space experienced overpressure from multiple directions simultaneously. I'm not going to detail what that does to human bodies. The reports do. They're specific. What I'll tell you is that the Republican Guard officers working in that bunker at 0447 hours didn't have time to react. The pressure wave moves faster than human nervous systems process information. The reports note the communications equipment. Most of it had been embedded in concrete housings for protection. The housings cracked. The equipment inside had compressed. Circuit boards don't compress well. Neither does anything else when the air pressure in a sealed room spikes to levels the human body can't survive. One detail appears in 2 of the 3 reports. The chronometers on the wall had stopped at different times within a 3-minute span. The engineers concluded the initial blast had damaged the power systems, and backup batteries kept some equipment running briefly. I don't know why multiple engineers thought this detail worth noting. Maybe it was the only thing in the bunker that still looked like it had a function, measuring time that had stopped. What the reports don't discuss much is the documentation, papers, maps, communication logs. These survived better than the equipment or the people. One engineer photographed a duty roster still clipped to a board near the entrance. The names are legible in the photograph. I have the names. I'm not including them here. The Al-Taji bunker wasn't the only hardened facility the F-111s hit that week. It was the first. The damage patterns were consistent across all of them. Penetration, internal detonation, overpressure, cessation. The weapon worked the same way in each location. What bothers me about the reports is how surprised the engineers sound. Not that the bomb worked, they knew it worked. That's why the targets had gone silent. What surprised them was how thoroughly it worked. One report uses the word comprehensive. That's a careful choice, not effective or successful. Comprehensive. These shelters were designed by people who understood blast physics and structural engineering. Soviet consultants had built similar facilities in their own territory. They'd calculated what these bunkers could survive. They'd been thorough. And it didn't matter. Not because the calculations were wrong, because someone had built a weapon specifically to make the calculations irrelevant. The ground team spent less than 2 hours in the Al-Taji bunker. They documented what they found, photographed the damage patterns, and left. The site was structurally unsound. The bomb had cracked the reinforced concrete in ways that made the entire complex unstable. The hardened shelter that was supposed to survive near nuclear strikes couldn't survive its own compromised structure. The reports went up the chain. The F-111 crews got confirmation their weapon performed as designed. And somewhere in Baghdad, other bunkers were still occupied for 3 more days. February 20th, Taif Air Base, Saudi Arabia. The F-111F crews got new target folders, hardened command bunkers, not the aircraft shelters they'd been hitting for weeks, not ammunition depots or bridge abutments, command facilities where Republican Guard leadership coordinated operations. Deep, reinforced, built to survive. The intelligence assessment ran 8 pages. I've seen 4 of them. The sections on structural composition read like engineering textbooks. Reinforced concrete thickness measurements, soil composition analysis, depth calculations. The bunkers were real, and they were occupied, and nothing currently mounted on coalition aircraft could touch them. The crews already knew this. They'd been watching other strike packages pound these facilities for weeks with 2,000-pound bombs. The bombs left craters. The bunkers kept transmitting. Major Jerry Hona commanded the 494th Fighter Squadron's detachment at Taif. He'd been flying F-100s and 11s since the early 80s. He read the target folders and asked the obvious question. What was supposed to penetrate 20 feet of Soviet-designed reinforced concrete? The answer sat in a climate-controlled hangar on the other side of the airfield. 2 weapons, unpainted, fresh from Texas, designated GBU-28. They'd arrived 3 days earlier on a C-141. Here's where the transition gets rough because the timeline fractures. These bombs existed on February 20th because engineers at Texas Instruments had been working the problem since late January. We need to go backward again to understand why 2 prototype weapons were sitting in Saudi Arabia waiting to be dropped on bunkers that weren't supposed to be vulnerable to anything. The crews didn't know the development story yet. What they knew was the weapons existed, they supposedly worked, and the target set included every major hardened command facility in Iraq. The briefing covered employment parameters, altitude, dive angle, laser designation procedures. The GBU-28 wasn't a standard weapon. It required specific delivery profiles. Get the geometry wrong and you'd either miss or hit at an angle that wouldn't penetrate. Captain John Tice flew one of the F-111Fs designated for the first strike. He asked about blast radius if the bomb worked as designed. The intelligence officer didn't have good numbers. The weapon had never been tested against an actual occupied bunker. The calculations suggested that internal detonation in a sealed space would be catastrophic. Beyond that, nobody knew. The target list had priorities. Al-Taji sat at the top. Republican Guard Coordination Hub, active communications, high-value personnel. Secondary targets included facilities near Al-Qut, Tikrit, and 2 bunkers in the Baghdad suburbs. The crews spent 2 days reviewing approach routes and designation procedures. The F-111F carried PAV-TAC laser designators. Point the laser, hold it steady, let the bomb guide, simple in concept, less simple at night over defended territory, while maintaining the precise dive angle these weapons required. February 27th got set as the strike date. Weather would be acceptable. The bombs would be ready. The targets would still be there. What the briefings didn't cover was what happened if this didn't work. If the GBU-28s failed to penetrate, there was no backup plan. The engineers in Texas had built these weapons in 3 weeks. There were 2 of them. That was the inventory. The crews went back to their quarters with the target folders. Captain Tice later said he spent the evening reading the structural analysis pages again. 20 feet of reinforced concrete, Soviet engineering standards, multiple hardened layers, and 2 bombs that were supposed to crack it all. Built in 3 weeks by engineers who'd been told this was impossible until somebody changed the definition of possible. Late January 1991, Eglin Air Force Base, Florida. The problem landed on Colonel Bert Swartz's desk with no good answer attached. Iraq had hardened command bunkers that could coordinate military operations through the entire war. Coalition aircraft couldn't touch them. The largest bunker busters in inventory, 2,000-pound GBU-24s, barely scratched the surface. Swartz ran the Air Force's penetrator weapons program. Solving impossible problems was supposedly his job. This one actually was impossible. You can't just build a bigger bomb. The physics doesn't scale linearly. Double the weight, you don't get double the penetration. The concrete absorbs energy. The weapon needs density, velocity, structural integrity through impact, and enough explosive yield left to matter after punching through 20 feet of Soviet engineering. Nothing in the American arsenal could do this. Nothing in anyone's arsenal could do this. The Soviets had designed these bunkers specifically to survive American bombs, and they'd done the math correctly. Swartz called Texas Instruments in Dallas. They built laser-guided weapons. Could they modify an existing penetrator design? No. Could they design something new? Maybe, but development and testing would take months. Months nobody had. Then somebody at Eglin suggested surplus artillery barrels, 8-inch barrels from decommissioned naval guns, solid steel designed to contain artillery charges, already manufactured to high stress tolerances. They were just sitting in storage because the Navy had retired the gun systems. Here's where it gets interesting. Take an artillery barrel, cut it to length, machine the exterior for aerodynamics, attach a guidance kit and tail fins, fill the back end with explosive. What you get is a projectile that's essentially a telephone pole made of hardened steel. It doesn't need to be sophisticated. It needs to be dense and fast and structurally sound enough to punch through reinforced concrete without disintegrating. The engineers at Texas Instruments pulled surplus barrels from Army storage at Watervliet Arsenal, New York. They cut them to 19 feet, weight without guidance systems or explosive, 4,400 pounds. Add the GBU-27 laser guidance package from the existing Paveway series. Add 600 pounds of tritonal explosive in the tail section. Total weight, 4,700 pounds. The design worked backwards from penetration requirements. How fast does it need to hit? How much steel? What impact angle? The math said this configuration should penetrate 20 feet of reinforced concrete and 100 feet of earth. Should being the operative word. Nobody could test it against an actual Soviet-designed bunker. They built 2 prototypes. That's all there was time for. The Navy barrels at Watervliet weren't infinite. The guidance kits existed in limited numbers. The machinists worked around the clock for 3 weeks. I spent 2 days trying to find documentation on structural testing. Nothing. The engineers ran computer simulations. They had blast calculations. They did not drop a prototype on a test bunker because there wasn't time to build a realistic test bunker, and even if there was, they only had 2 weapons. February 17th, the first GBU-28 left Texas on a C-141. February 18th, the second one followed. Both weapons flew to Saudi Arabia untested against real-world targets. The engineers were confident the physics worked. Confidence and verification are different things. The F-111F crews at Taif got the weapons on February 20th with instructions on employment parameters derived entirely from computer models. Drop altitude, 10,000 to 15,000 feet. Dive angle, 30 to 45 degrees. Laser designation, continuous through impact. What happens after impact was theoretical until someone actually dropped one on a hardened bunker with people inside. The theory said catastrophic overpressure in enclosed spaces. The theory didn't have video evidence or post-strike damage assessment. That came 7 days later over Al-Taji. The Soviets sent engineers to Iraq in 1982. Not advisors, engineers. The kind who'd built hardened facilities in the Urals and knew what American bombs could do because they'd studied every weapon in the NATO inventory. Iraq paid in oil revenue, and the Soviets delivered bunker designs that were supposed to survive anything short of direct nuclear strikes. Supposed to being the critical phrase, but in 1982, the math checked out. The design philosophy came straight from Soviet strategic doctrine. Americans had precision-guided munitions. Fine. Build structures where precision doesn't matter, because even a direct hit won't penetrate. The math was straightforward. American bombs topped out at 2,000 pounds for bunker work. Calculate penetration depth at terminal velocity. Add safety margin. Build thicker than that. Al-Taji got 20 feet of reinforced concrete over the main operations center. Not standard concrete, Soviet-specified mixture with hardening agents. Rebar spacing at 6-inch intervals in a grid pattern. The rebar itself was high-tensile steel. The concrete poured in layers with curing time between each pour to prevent thermal cracking. Over that, 12 feet of compacted earth and rock. This wasn't fill dirt, graded aggregate in specific sizes to absorb and dissipate blast energy. The Soviets understood that the earth layer mattered as much as the concrete. It changed how the shock wave propagated. Below the operations center, foundation work went down another 30 feet into bedrock. The entire structure was designed to transfer blast energy downward and outward, away from the protected spaces. The Soviets had tested similar designs at their own facilities. They knew the physics. The bunker had 3 separate entrances through angled tunnels. You couldn't shoot down the tunnel and hit the operations center. The geometry didn't allow it. Each tunnel had 2 blast doors. Each door weighed 5 tons and was designed to seal automatically if external pressure sensors detected a blast wave. Ventilation was redundant. 4 separate air supply systems with intake vents scattered across the complex. If one system failed, 3 others kept the bunker operational. The vents themselves were baffled and angled to prevent blast waves from propagating down the shafts. Communications ran through buried concrete conduits. Multiple pathways for redundancy. The Soviets assumed Americans would target communications infrastructure. The design made sure one cut cable wouldn't isolate the facility. Power came from 3 sources: external grid connection, diesel generators inside the bunker complex, and battery backup rated for 72 hours. The generators sat in their own hardened rooms. You'd have to crack multiple structures to kill power completely. The Republican Guard officers who worked in these bunkers knew they were protected. Their Soviet consultants had shown them the penetration calculations. American GBU-24 penetrator bombs had a maximum penetration depth of 11 feet through reinforced concrete under ideal conditions. Al-Taji had 20 feet. The math wasn't close, and the math was correct. For weapons that existed in 1982 and still existed in January 1991, these bunkers were impenetrable. The Soviets had done their homework. They'd calculated conservatively. They'd built to specifications that exceeded American capabilities. What they hadn't calculated was someone cutting up artillery barrels and dropping them from F-100s and 11s. That weapon didn't exist in any NATO inventory assessment. It didn't exist in any engineering database. It didn't exist until 3 weeks before it showed up over Al-Taji. Soviet bunker design philosophy assumed American weapons development followed predictable patterns. Incremental improvements, larger warheads on existing platforms, better guidance systems. What it didn't account for was someone solving the problem backwards by making the weapon simpler, denser, heavier. The bunkers were engineered to survive American sophistication. Nobody engineered them to survive a 4,700-pound steel telephone pole dropped at 600 miles per hour. February 27th, 0430 hours. 2 F-111Fs lifted off from Taif carrying weapons that had never been used in combat. Captain John Tice flew lead aircraft. His weapons systems officer, Captain Bill Bunker, handled the pave tack laser designator. The GBU-28 hung under the center line. The weapon looked crude compared to standard munitions. Unpainted steel, guidance package bolted on, fins that seemed almost comically small for a 4,700-pound bomb. The flight plan took them north into Iraq, then west toward the Al-Taji complex. 15 miles north of Baghdad. Known air defenses, active SAM sites within engagement range. Ideal conditions for precision bombing at night over hostile territory. They hit the initial point at 4:44 hours. Tice put the F-111F into a 30-degree dive. The targeting computer showed the bunker complex below. Infrared signature showed nothing. The hardened structure was cold. No thermal bleeding from the ventilation systems. Bunker activated the pave tack. The laser designator locked onto the aiming point. The engineers had been specific about this. Target the center of the structure. Not the edges, not the entrance tunnels. Dead center, where the concrete was thickest. That's where the operations center sat below. The GBU-28 released at 10,000 feet. Tice pulled out of the dive. The weapon fell for 8 seconds. Standard procedure was to maintain laser designation through impact. Bunker kept the crosshairs steady. The bomb corrected its trajectory with small fin adjustments. The guidance package worked exactly like every other Pavway series weapon. What came after guidance was different. Impact velocity, approximately 600 miles per hour. The GBU-28 hit dirt and rock first. The weapon didn't slow. The nose cone, machined from artillery barrel steel, punched through 12 feet of aggregate without deforming. It hit the first layer of reinforced concrete. Soviet engineers had calculated this layer would stop any American bomb. The steel nose cone compressed slightly, maintained structural integrity, kept penetrating. The weapon crossed the first concrete layer in under a second. Second concrete layer. Rebar grid at 6-inch spacing. High tensile steel, the weapon sheared through it. The rebar was designed to catch and deflect projectiles. The GBU-28 massed 4,700 pounds and was moving at 600 miles per hour. The rebar bent and snapped. The weapon entered the operations center 19 feet below the surface. The fuse functioned. 600 pounds of tritonal explosive detonated inside a sealed, reinforced concrete room. Tice and Bunker were already 3 miles away when the explosion occurred. They didn't see it. The blast happened underground, inside a hardened structure. No fireball, no visible secondary explosions. Just earth and concrete, absorbing 600 pounds of high explosive in an enclosed space. What they saw was the infrared signature change. The bunker went from cold to hot in the span of 2 seconds. Thermal energy venting through the entrance tunnels. The blast doors had failed. The overpressure had exceeded their rating by margins the Soviet engineers hadn't calculated for. The communications intercept confirmed it 3 minutes later. Al-Taji had stopped transmitting mid-sentence. Coalition SIGINT crews noted the silence. They didn't know why yet. That assessment came later after analysts correlated the timing with the F-111F strike. Taif and Bunker flew back to Taif. The mission debrief took 40 minutes. The weapon had functioned. Target had gone silent. Bomb damage assessment would come from satellites and possibly ground teams if the advance reached Al-Taji. What nobody said during the debrief was what everyone understood. The GBU-28 worked exactly as designed, maybe better than designed. The Soviet calculations were wrong. Every hardened bunker in Iraq was suddenly vulnerable. The second F-111F, carrying the second GBU-28, was already being prepped for the next mission. By 800 hours on February 27th, Coalition Signals Intelligence had logged something unusual. Multiple Republican Guard command nodes had stopped transmitting. Not degraded signals. Complete silence. The Al-Taji bunker went quiet at 4:47 hours. A secondary command facility near Tikrit stopped responding at 6:15 hours. By midday, 4 separate hardened facilities had ceased communications. The pattern was clear even before bomb damage assessment confirmed what had happened. Republican Guard divisions in the field started reporting difficulties receiving orders. The communications network had been redundant specifically to prevent this. Multiple command bunkers, multiple communication pathways, overlapping coverage areas. Knock out one facility and 2 others pick up the coordination load. Except now, 4 facilities were gone in the span of 6 hours. The redundancy had assumed conventional strikes that might damage but not eliminate hardened structures. Nobody had built redundancy for weapons that turned command bunkers into sealed tombs. One intercepted transmission at 11:30 hours showed the confusion. A Republican Guard tank battalion commander requesting instructions for withdrawal toward Baghdad. The response came from a different command facility than usual. The new coordinator didn't have updated intelligence on coalition positions. The orders were 12 hours out of date. The fracturing wasn't total. Iraqi forces didn't collapse into chaos, but the command network that had been operating with Soviet-level redundancy was suddenly running on whatever facilities the F-111Fs hadn't hit yet. And those crews had more GBU-28s being flown in from Texas. Here's a detail that appears in one signal's intercept and nowhere else. A Republican Guard logistics officer reported a generator failure at a facility designated Site 23 in the communications logs. The timestamp is 7:40 hours on February 27th. The intercept notes the facility requested a backup generator be delivered by 1400 hours. I spent 3 days trying to correlate Site 23 with known bunker locations. Nothing matches. The facility isn't on any target list I've found. The intercept mentions generator failure, not bomb damage. The request for a backup generator suggests the facility was still occupied and operational. The detail appears once in the declassified intercept logs. Site 23 isn't mentioned again. I don't know if the generator was delivered. I don't know if the facility was hit later. I don't know why a logistics officer was worried about generator failure while 4 command bunkers had been eliminated in 6 hours. It's possible Site 23 was a minor facility that didn't matter. It's possible the generator failure was unrelated to the strikes. It's possible this detail means nothing, and I'm wasting words on it. But it's in the intercept log at 7:40 hours on February 27th, and I can't find any follow-up. What I can confirm is that Republican Guard command capability degraded significantly after February 27th. Not because units stopped fighting. Because the hardened facilities coordinating multiple divisions had been eliminated with a weapon type nobody had prepared for. The Soviet engineers who designed these bunkers had calculated for conventional penetrator bombs, near-miss nuclear strikes, and sustained bombardment. They'd built structures that could survive all 3. What they couldn't account for was a weapon that didn't exist in any calculation set until 3 weeks before it mattered. By February 28th, 8 hardened command facilities had been struck with GBU-28s, 6 confirmed eliminated, 2 with uncertain status pending ground assessment. The redundant command network was no longer redundant. And there were more bombs coming. Texas Instruments had ramped up production. The artillery barrels were available. The guidance kits existed. What had been a two-weapon prototype program was now a production line. The Al-Taji strike proved the concept. The next 3 days turned it into a campaign. February 27th evening, another F-111F hit a Hardened facility outside Tikrit. Same weapon, same delivery profile, same result. Communications ceased. The bunker that had been coordinating Adnan division movements went silent. February 28th, two more strikes, one near Al-Qut, one in the Baghdad suburbs. Both facilities were on the priority target list. Both had survived weeks of conventional bombing. Both stopped transmitting within minutes of GBU-28 impact. The crews were learning the weapon's characteristics in real time. Captain Tice flew 3 of the first 5 missions. He reported that the GBU-28 was less forgiving than standard penetrators. The dive angle mattered more. Get too shallow and the weapon skipped or tumbled. Too steep and you risked overshooting the aim point in the darkness. But when the geometry was correct, the weapon performed identically every time. Penetration, internal detonation, silence. The consistency was almost mechanical. The Soviet-designed bunkers all failed the same way. By March 1st, F-111F crews had struck 8 hardened command facilities. They'd lost 0 aircraft. Iraqi air defenses had engaged them. SAM launches, 8A fire, the standard response. The F-111Fs flew through it the same way they'd been flying through Iraqi defenses for 6 weeks. What changed was target availability. The intelligence community kept updating the list. More bunkers, more hardened facilities, more locations where Iraqi leadership might be coordinating from underground. The GBU-28 inventory was growing faster than the target list was shrinking. The crews started recognizing patterns in the bunker designs. Most followed similar Soviet specifications. Same concrete thickness, same layered construction, same entrance tunnel geometry. The Russians had sold Iraq a template, and Iraqi engineers had built to standard. That standardization made targeting easier. If one bunker failed at 20 feet of penetration, they all would. March 2nd, a strike on a facility near Basra. This one was different. Signals intelligence suggested it coordinated southern sector defense. The bunker sat in defended territory with multiple SAM rings. The F-111F crew got through, designated the target, released the weapon, and egressed without incident. The bomb hit. The facility went silent. Post-strike assessment showed the same damage pattern. Penetration, internal detonation, structural failure from overpressure. The bunker's own design killed everyone inside by containing the blast. What the crews didn't discuss much in debriefs was what they were actually doing. The clinical language covered it. Target eliminated. Facility neutralized. Communications ceased. The reports didn't describe what happens to human bodies when 600 pounds of explosive detonates in a sealed room. The ground teams who eventually entered these facilities wrote different reports. Those got classified higher. I've seen excerpts. The language is less clinical. By March 3rd, when the ground war was essentially over, F-111F crews had eliminated every priority hardened command facility in Iraq. The bunkers that were supposed to let Iraqi leadership coordinate through the entire war had become death traps. The Soviet engineers had built them strong enough to keep explosions out. That same strength kept the GBU-28 explosions in. The weapon worked better than the engineers at Texas Instruments had calculated. The penetration depth exceeded projections. The structural integrity through impact was higher than computer models predicted. 8-inch artillery barrels turned out to be ideal for punching through Soviet-designed bunkers. What nobody anticipated was how thoroughly the weapon would work. Degraded capability was the goal. Elimination was the result. There's a difference. The difference sat in hardened facilities across Iraq, where everyone inside had stopped existing simultaneously. February 13th, 1991. 2 weeks before Al-Taji, an F-117 dropped 2 GBU-27 bombs on the Al-Amiria bunker in Baghdad. The facility looked like every other hardened shelter on the target list. Soviet design, reinforced concrete, active air defense protection. Intelligence assessments indicated military use. Communications intercepts suggested command and control functions. The bunker went on the target list. The bombs penetrated. Both detonated inside. 400 people died. Most of them were civilians, families sheltering from the air campaign. The bunker had military functions, but it also had civilian refugees who'd been using it as protection since January. Intelligence had missed this. The assessments had been wrong. The targeting had been approved based on intercepts and structural analysis, not on knowing who was actually inside when the bombs hit. I'm including this here because it's relevant to what the GBU-28 campaign became 2 weeks later. The weapon itself doesn't discriminate. It penetrates hardened structures and detonates inside. What's inside matters, but the bomb doesn't know and can't know. Al-Amiria changed targeting procedures, more scrutiny on hardened facilities, better intelligence on occupancy. Cross-reference communications intercepts with human intelligence. Make sure you're hitting military command structures, not shelters full of civilians. The GBU-28 strikes on February 27th and after benefited from these updated procedures. The target list got refined. Al-Taji, Tikrit, Al-Qut, the Baghdad suburb facilities, all confirmed as military command bunkers, active communications, Republican Guard coordination, high-confidence intelligence. But here's what bothers me. The GBU-28 was more capable than any weapon used at Al-Amiria. Deeper penetration, larger warhead. When it detonated inside a sealed structure, nothing survived. The overpressure was absolute, which meant the margin for error disappeared. Hit the wrong bunker with a GBU-24 and you might partially collapse it, might kill some people, might leave survivors who could evacuate. Hit the wrong bunker with a GBU-28 and everyone inside ceases to exist. The weapon's effectiveness eliminated the possibility of partial mistakes. The intelligence community knew this. The targeting became more conservative after Al-Amiria, even more so once the GBU-28s arrived. Only high-confidence targets, multiple source confirmation. Verified military use? 8 bunkers got hit with GBU-28s between February 27th and March 3rd. All 8 were legitimate military command facilities. The intelligence was correct. But the weapon's capability meant that getting it wrong once would have been catastrophic in ways that conventional bombing couldn't match. This isn't speculation about what might have happened. This is acknowledgement that a weapon capable of absolute elimination inside hardened structures requires absolute certainty about targets. The crews dropping GBU-28s weren't just penetrating bunkers. They were ending everything inside those spaces simultaneously, with no survivors, no partial damage, no second chances. Al-Amiria happened with less capable weapons and killed 400 people. A GBU-28 dropped on a similar shelter would have killed everyone inside just as thoroughly, but with a weapon specifically designed for that level of comprehensive destruction. The difference between the Al-Amiria tragedy and the GBU-28 campaign was intelligence quality, not weapon restraint. The bomb itself was more lethal, more absolute, more final. What prevented another civilian casualty incident was better targeting information and more conservative approval processes. The weapon didn't care what was inside the bunkers. The artillery barrel steel penetrated Soviet-designed concrete the same way, regardless of occupancy. 600 pounds of tritonal explosive produced the same overpressure whether the bunker held Republican Guard commanders or civilian families. The crews knew this. The intelligence officers knew this. Everyone involved knew that the weapon's capability had exceeded the margin for error. His name is Khalid. He's 71 now. He was a Republican Guard signals officer in February 1991, assigned to the Al-Taji command bunker. I talked to him in 2019 through an intermediary. He'd left Iraq years earlier, lives in Europe now. He agreed to discuss what he remembered about the bunker and the night it was destroyed, with the understanding I wouldn't specify his location or full identity. He wasn't supposed to survive. His duty rotation had him scheduled for the overnight shift on February 26th to 27th. He would have been in the operations center at 0447 hours when the GBU-28 hit. 2 hours before his shift started, a colonel pulled him for a courier assignment. Documents that needed to be delivered to a Republican Guard division headquarters near Baghdad. Minor administrative task. The colonel could have sent anyone. He sent Khalid. Khalid left Al-Taji at 2:30 hours on February 27th. He was 8 miles away when the bunker was struck. He didn't hear the explosion. Nobody did. The detonation happened too deep underground, contained by the structure. He learned what happened when he returned to Al-Taji 3 days later as part of a Republican Guard assessment team. The exterior looked intact. The entrance tunnels were damaged. The blast doors had blown outward. What he remembers most clearly is the smell. The bunker's ventilation had failed. The air inside had become toxic. The assessment team wore breathing equipment. Khalid didn't enter the main operations center. The senior officers went in. They came out after 20 minutes and prohibited further entry. Khalid knew everyone who'd been working that shift. 17 officers and enlisted personnel. He'd served with some of them for 3 years. He'd eaten meals with them, shared quarters, worked overlapping shifts. All dead at 4:47 hours, all simultaneously. The assessment team's preliminary report noted that death had been instantaneous for everyone in the operations center. The overpressure alone would have been unsurvivable. He asks himself about the courier assignment. Why that night? Why him specifically? The colonel who gave him the assignment died 6 weeks later in an unrelated incident. Khalid never got to ask why he was chosen. He doesn't attribute it to divine intervention or fate. He's not religious in that way. But he thinks about the randomness. 2 hours earlier departure time, and he would have been in the bunker. The colonel sends a different signals officer, and Khalid is in the operations center when the bomb penetrates. What he remembers about the bunker is the confidence everyone had in its protection. The Soviet engineers had explained the design. 20 feet of reinforced concrete, multiple hardened layers. The structure could survive near nuclear strikes. The officers believed this completely. That confidence lasted until 4:47 hours on February 27th. Then it became irrelevant. The Soviet calculations were wrong, or the American weapon exceeded what anyone thought possible. Either way, the bunker failed absolutely. Khalid left Iraq in 1996. He doesn't discuss the war much with people who ask, but he agreed to talk about Al-Taji because he thinks someone should remember what happened there beyond the technical reports and bomb damage assessments. 17 people died in that bunker. He knew their names, their families, their ranks. The war ended a week later. If the ground offensive had started 2 days earlier, they might have survived to surrender. If the courier assignment had gone to someone else, Khalid would have died with them. He's 71 now. He still thinks about the colonel who sent him out that night. About why him? About the arbitrariness of who survives and who doesn't when someone drops a 4,700-pound bomb through 20 feet of reinforced concrete.